Thank you. So today we will take like 30 minutes to recover the topic that we skipped yesterday. As the machine that hosts Open on Demand have some network issues. So we will start from there. And after we will continue with our normal agenda. So basically I will still 30 minutes, I think, from the terminal multiplexing to at least show you a little bit how Open on Demand works. So it's like this. Okay, now let's start here with. So Open on Demand. Yesterday we talked about that, but we never have the opportunity to do anything. This is a web service that allow you to create interactive executions that, from the user's perspective, from your perspective, is running on a web interface. You are in front of on your own browser, but you are using the resources of one of the compute nodes on Thor. So you can request a certain amount of memory, time, and cores, and CPU cores, and they will be yours for a certain amount of time for running executions. Typically RStudio and Jupyter, but some other things can be done also with this thing. So you start like this. I will actually type on the chat because there is the data here, which is the link. So that is the link for Open on Demand. When you just go there, ask for your credentials, password, Duo, the usual thing. And you land here. So this is called the dashboard for Open on Demand. And all that we will be doing is right on the top of it. So we are connected here only to Tor Finland. Open on Demand is available only for Tor. So let's start with something simple here. You click here on interactive apps. And we have, for example, this Jupyter notebook. Here you get like a formulary where you fill the corresponding fields, for example, for opening a Jupyter notebook session. So here I'm selecting Python, the traditional Python 3.95 or compiled over GCC 11.1. You can, if you want, add more modules. We will see that in a minute. But that is the base Python that you will be using, for example, for the execution design. And the queue, remember that yesterday we talked about queues. The standby queue has a limit of 4 hours. We have a debug queue for 1 hour, but this is just for testing. It's a small queue, just one machine. And we have a queue here for interactive executions with GPU. If you plan to use GPU, this is the queue that you need to use, the COM GPU interface. Also with a 4 hour limit. So I am asking for 4 hours. I don't really need to ask for 4 hours, so I will put just 2 hours. It's perfectly okay. How many cores I will be using? So remember that the fact that you use more cores not necessarily translate in you being able to get the job done faster. It also requires that your code is capable of supporting parallelization, which is not necessarily the case for every code. So if you know that what you are using is capable of doing multiprocessing, in the case of Python, we will be multiprocessing. You can ask for more cores, more than one core. But I will be asking for 8 just for this demonstration. Number of GPU. There is something to say here. If you are using this kind of Python, for example, and you are and your code relies on NumPy, SciPy, those kind of numerical intense libraries, you could end up having an extra performance boost by requesting more cores, just because those NumPy and SciPy were compiled on top of OpenBLAST, and OpenBLAST was compiled with multi-thread. So all the linear algebra operations that you do here, if using this Python, will be multi-threaded somehow. So eventually, if you are dealing with huge matrices, you could get some advantages on requesting multiple cores. That will be the exception. Let's say in general, most of executions will be serial in Python. There are rare cases where people uses multiprocessing for increasing performance. So if you are asking for GPU cars, you have to change the queue here for a queue that give you GPU access. So I'm not requesting that. And you can add more modules here if you want, for example, to run a simulation or something, and you need a specific software that we have provide a module for it. So you can add those modules here. So I'm executing here the Jupyter, and that's it. You hit launch, and you end up in this new screen where you just wait for a couple of minutes, so a few seconds most time, and you get a button here. Okay, so now you got assigned one particular compute node. This is the name of the compute node that was assigned to you. It was assigned one node with 8 cores for 2 hours. So you get all the information that we need, that we request here for this session. You just click here, connect to Jupyter. And this is this is inside Jupyter, which provides a notebook application and also a relatively simple but useful file manager. So those are my files on my account, and here I have a bunch of IPython notebooks, for example, that I could execute. But let's start with something simple, something from scratch, so we demonstrate how this works. I will create a new Python session here, Python 3. And that's it. So for those of you who are familiar with Python, these commands probably will know. We'll be importing, for example, matplotlib, and you hit Shift Enter, and that executes the command. I will be importing, for example, NumPy, SMT. Those are the typical way load those modules. And let me see. Oh, and so now plt.plot and np random and let's say 1000 dots red dots. So you can create plots. You can import, you can execute interactively on this notebook. You can also add here and make this an actual notebook or like a report, and you convert this into Markdown, and it would be a title. You can install, okay, the procedure for doing something here. You can describe, make plots, all that. So for those who are familiar with Python and in particular with Jupyter, this is out there. I'm using right now all the resources of 8 cores on one of the compute nodes. It means that I have all, so if you see on which machine I am, I am on this machine with 40 cores. I am actually executing here. This is a way of executing a bash command or a shell command, command line interface inside the notebook with an exclamation mark. So I am on a machine with 40 cores. I got access to 8 of those cores for 2 hours. So that is what we have. Possibilities of this. Let's explore a different one. Not sure if I will get it so quickly, but I will request, for example, this one. Let me see if I can request this one here. So this is another set of images for Jupyter. And that I would like to demonstrate this because this is one of those that not TensorFlow. Well, yeah, this one. So those here are official Jupyter notebook images with a preload set of packages. So here, Scala, R, Spark, for those who are into big data analysis. So this is one notebook that will give you a lot of utilities, functionality related to that. If you are in data science, this one will provide a good set of packages in Python for data science, for visualization, and for analysis itself. A more traditional Python, PySpark is here. A notebook, Jupyter notebook with R installed and a set of packages related to working on with R inside Jupyter is here, scientific Python, and I'm selecting this one because I would like to show you that I'm unable to load this. I will not demonstrate actually any execution. That's beyond the 30 minutes that I have. So let's see how easy they can get this. So another thing, you can have multiple sessions. So I am still having this session running. I can go here and execute more stuff. And this is still running. I am still using those those 8 cores if I need and I need them. And here I'm using, and here I'm having a different session where I request 4 cores, 1 node, in one of the GPU machines. So I hit here, I open a new Python notice that I have in I have access to one GPU. This is a Quadro P6000. So I request, the machine has actually 3, but I request 1. So only 1 is visible for me here. And I can import TensorFlow, yeah. And after that, I can execute, I can run neural networks, deep learning operations, training, using the GPU for training, for up to what I request 4 hours. In this case, I request 4 hours. So I have 4 hours to run my training, for example, of a neural network interactively. So I can see how those epochs move, how the precision is getting better or something. So I can monitor the execution, which is very handy when you are, for example, first training a neural network. Now, another one, RStudio. It's right here. So all those applications are here. So interactive applications, RStudio. Here you can select the version of RStudio that you want to use. And the RStudio server. So this one, for example, is a good choice. It's RStudio. It's relatively old, the RStudio server, but runs a very recent version of R 4.04. So this is a good choice. I will be using a standby 4 hours. And here nodes, it has a different meaning. Here nodes mean cores. It's because this was created differently. So the terminology here is not so consistent. Nodes means cores. Launch. So this will be my 3rd session inside Jupyter. Here I request 4 hours, 2 cores. I got the button here ready for me. And this is Jupyter, the Jupyter RStudio. I have a workspace with a couple of things. So it will preserve your environment. It will read the history file, and here you can see all the packages available on this image. It's running inside a Singularity image. We will talk about that, I think, today, about Singularity. But this is the main thing. So we can have this. And just to complete something, there is an alternative for this, for the Jupyter. You can run the new version of Jupyter that is called Jupyter Lab. I will show you how that works. You can run, so we have kernels for running. Of course, those official images, they will give you PySpark, which is another image for that. And we have a capability to run Julia. If you know that language, it's a very high performance language, interactive, still very flexible language. That can run inside the Jupyter notebook, no problem. R. Those are main languages. So this one got stuck. I probably need to check this one. Something is wrong. Okay, so we got we got 5 minutes here to show you this. Other things that you can do with this. Here you can have access to a terminal from the web browser. If this is failing because I'm using Internet Explorer, or I don't know what it's not working. I'm not familiar with Internet Explorer, so I don't know if that is the reason or not. Why I'm not getting the shell. Here, here. Okay. Here I have a file browser. So where I can see, for example, a text file, I can view the text file directly from the browser. So for the small text files, this is an alternative. And here, if I have an image, let's see if I have an image here. Okay, you can also see plots, images there. That works. You can move files, rename files, create folders. So the basic stuff that you want to do with a file manager, you can do here. Something else here, jobs. So you can monitor the jobs that are running on the cluster, even not only the interactive jobs, but also the jobs. But I'm not seeing, it's not working. Sure. This is not great. Okay, so basically that all those applications are here, and yeah, that's what I imagine. Yeah, I imagine this is probably an old browser. It's Internet Explorer now. They changed something for Edge or something like that. I don't know. It probably is due to the age, the old browser. So let's go for something else. Yeah, 30 minutes. I still 30 minutes of this. So let's go for next topic. Terminal multiplexing. So let me see. I will describe and I will, in the meantime, download. Cool. So on Monday, we start learning about entering the cluster, opening a terminal, getting a command line interface, and start typing commands. When you move into a more advanced usage of the cluster, you will most likely be launching multiple jobs. You can perfectly launch hundreds of jobs on the cluster, and they will run for days to a week. And so you would like to monitor the execution of those jobs. You would like to write more inputs, so adapt some inputs for more jobs. You would like to see the output of those jobs that are finishing. So you will start interactively interact with the cluster in multiple ways, probably simultaneously. So for that, it's a good idea to have a way of having a terminal, or actually multiple terminals, that survive in the case that you just close your browser, or you close your computer, you lost internet connection, and you want to preserve the state of your work on those terminals. Otherwise, you will have to reconnect and go to the correct folders for a bunch of terminals. So it's a waste of time. So what I will show you is how to use something called a terminal multiplex for doing that. The command is tmux, which is the terminal multiplexer that we use today. But before I need this, I will be downloading Right. see if I can make this bigger. Okay. So now I am on Torrent. Notice I'm on Torrent. And so the first thing is to create okay. First is to create a terminal, a TMOX session. You just type TMOX. Notice that when you create a terminal, a new TMOX session, that's the name of this, you have here on the bottom one window. Okay, the name of this is one window. We can create multiple windows here. So Control B. Oh, okay. How this works? All the commands that. So I hope that you start doing this because if you face any you got stuck or something, please tell me because it's usually this. It's usually the typing of commands that become confusing. So everything is described here. So just in case, it's right here. The commands that you have to type. And everything starts with Control B by default. You can change that later. Control B something B and another key. So I will be hitting Control B. I raise hands and I hit C, and I created a new window. On this window, for example, I will go to my Scratch, and I will list my files. I can go back here and list my files here. Now imagine that I just close the session. I close my computer, the session is no longer there. I start a new session. At least you have to type, you have to enter again on cluster. These steps, you have to do it again. There are no controls to that, but now if I want to recover my session, I just hit TMOX space A. And everything is there. So all the folders where I am and the kind of things that I'm doing is preserved, which is a good thing. So now let's review terminology around this. So we have two windows here. Each window, they are identified here on the bottom with a number and also with a name. So we can create multiple windows. I will create a few more. Control B, C, a new one. Control B, C, and I have another one here, Control B, C. So I have now from 0 to 4 windows. You can change between windows, so you can switch those windows with Control B and the number that they have associated. So Control B1 and you move to window number 1. Control B3 and you are moving to window number 3. So you can have more than 10 from 0 to 9, but you can only address the first 10 with the digit. Another thing that you can do is to change names to those windows. Control B, comma. You can put some name here. So this is project 1. So you can put a name to them, so you know what you are doing there. So in some of them, for example, will be here. I would like to do, for example, post processing. This will be dedicated sometimes it's better just to have some short name like that, so you can accommodate all the names here. Control B2 here. I am, for example, monitoring jobs. So I will be running QStat. So I will be running QStat or QStat. Yeah, I will be running QStat. So this one will be dedicated to QStat. So I put a name, a tag to this window, so I know that I'm doing that. What else I can do with this? So I will create a new one. This is one window. So I have window number 5. It's called Bash by default. And now inside one window, I can create panes. I can create like panels inside. And you can create them in 2 ways. One is Control B %, and you are splitting the window vertically. You can type Control B and double quotes, and you can split horizontal. So now we have 3 panes here on window number 5. Another thing that you can do, for example, if you want, there is one way for making a clock here, Control BT, and you have a clock running here. You can cycle between those terminals with Control BO. So here I will be running top and Control BO here. So here I will be running something like a watch to the something like this. So I can have monitoring strings there permanently with multiple panels here. I can zoom in one particular panel if I need to do something, or I want to see something bigger with Control B Z, and I will get a zoom to one of those panels. So you will see here the number 5. They have a star and they have a Z. It means that there are more panels that are hidden there. So Control B Z will return to the original configuration. You can have here, you can change the layout of those panels. Those panes here, Control B space. So you can have those panels vertical, all of them horizontal, arrange this one big on top and a couple of smaller ones. So they have multiple layouts that you can cycle. It depends if you have 3 or you have more. It will select different layouts that make sense for the number of panels that you are creating. So you can move to another panel here. Let me see, let me review if I am missing something that I forgot to tell. So we create a new TMUX session with this. TMUX sessions will survive. You disconnecting from the internet, you're closing your laptop and moving to a different place. So they will survive that. The only thing that they will not survive are the rare events where we need to shut down the head node. In those cases, and we will have to do that, let's say, once, maximum a couple of times in 1 year. So it's something that the TMUX session will survive for several months, usually. So that's okay. So when you disconnect and you reconnect, you arrive home and you will continue doing something. You will reattach with Tmux space 8, and all that session will be recovered, and you will have you can continue. And you can create a new session here. So I can close this session with Control B D. Oh no, Control B D, and you detach the session. And you can reattach this session. Control B D is a detach, and you can create more sessions here. So this one is an entire new session where you can have multiple things here. So I will create, let's say, 3 windows here. I will split this one. Just 3 panels here. Will be ordered those like this. I will be running here top. I will be Control B O will cycle for something else. Let's use that. Now you can see all the sessions that you have and the windows that are there and the number of panels that are there. So sessions, windows, and panes. All those things you can move between them with Control B W. So now you see that I have here one session here with panels. Here I have 6 windows in this other section, and I have here 3 windows. This window, by the way, is from the previous section that I was. So it's something that I was doing before. So I actually have 3. I create 2 today, but I actually have 1 before. So this one is there. 6 windows here. This window has 1 pane, 1 pane, 1 pane, 1 pane, 1 pane, 4 panes. This one here had 3 windows, and actually showing me like a small snapshot of what is in there. And this one has 1 pane, 1 pane, 3 panes. So you can move around. The idea is that you organize your projects, your interaction with the cluster in a way that makes sense to you, but having multiple sessions, windows, and panes in a way that you can have all your work at hand when you need it. So this is a time-saving tip. So let me see if I am missing some. So there is also a way for creating the new sessions, and you can put a name to that session. There are ways for moving between sessions with this. So Control B and parentheses. So okay, this. Imagine that this one is quite awesome. Let's see. I will go to my Scratch. Let's see. Okay, I will generate something that will have a long output. Probably too long. I don't want to do that. So you can scroll up on you can scroll this window, and for doing that is Control B and the square bracket, opening the square bracket, and you will see here that you can scroll up to 1917 lines. So you can go up and start scrolling. For example, if you are running something and that is producing output directly on your screen, you can at any time go and go back and review the simulation, how that is going with this trick. So also you can go and select areas, regions, control space. So it will not work on Tmax because it will capture my control space. I need to figure out where this is captured. But on Mac, on Linux, where you don't have this kind of utilities, that should work without problem. So yes, so that is the thing that I'm not able to demonstrate, the highlighting the Mario Sprite. But that's something that I eventually could fix if I just change the settings somewhere in here. I did it last time. It was like control space. This one. I need to remove this and deassociate this. Okay, let me see if I have something more important to show here. Okay, final things. Once you familiarize yourself with Tmux, there are more things that you can do. You can tune which will be the couple of keywords that you will use to trigger all those commands that I show you. You can also change the visual appearance of those. So here, just for demonstration, I am showing you one example of all the kind of settings and tuning that you can find on internet, for example, about changing the backgrounds, the way that those the text appears on the bottom of the terminal, showing, for example, the CPU load of the machine, of the time, or the temperatures, if you want. There are a bunch of stuff here that you can tune those things. So now for the next 10 minutes, the exercises are to create here, create 3 sessions. You will be creating 3 sessions. So you can go create one, detach, create a second one, detach, create a third one. So you start familiarizing with those. Or you can go and rename the session, rename those sessions with Ctrl+D $, create windows on those sessions, create 3 panes on one of those sessions. So basically familiarize with those. And if something doesn't work as you expect, please tell me so I will help you. And here, I wrote here Spruce, but it's irrelevant which cluster you are. So you can create here panels and you connect if you want, for example, to connect a different machine. That is actually something that I do. So I have one session from connecting entirely to a Spruce, another section connected only to me, and another one is for more things. So this is one thing that you can do. Create a clock. So basically, instructions for exposing you to the commands that you need or you want to use here for that. Also, you can kill sessions. There are instructions, I think, here for killing, creating sessions. So let's see if I can here. How you destroy sessions, destroy panes. This is quite useful. So take your time, explore a little bit Tmux, and over the hour, we will move on to the next stuff. I'm just curious because we have just 5 participants. Eloisa and Ming Xian, could you type on the chat which college you belong, or so I get an idea a little bit about you, or because now we have a few people, so I can eventually be more personalized on those things. So I would appreciate if you just type college and
Hello, my name is Eloisa Vendemiati. I'm from Brazil. I'm here doing my postdoc, and I'm using the HPC to analyze my sequencing data
on this computer. So please just type on the chat. So there is a chat, and you just type there, because this computer here and this. You have it. Well, yeah. Well, someone around here has a speaker, so I can hear you. Hello. Oh, hello.
Hello.
Hello. Okay, so which college are you? Where from?
I'm from the Davis College of Agriculture.
So both, I think you're right. Let me see. What is it? So both. Okay. Do genomics? Do you what? It's genomics mode.
Yeah, I'm working with tomato, improved of tomato. But with the HPC, I'm working with the sequence data.
Okay, so genomics, bioinformatics.
Yes.
Okay, and same thing for your colleague.
What?
Your colleague.
The sound, it's very strange for me.
It's making a feedback. It's making a feedback. That's the problem with it. Because it's very. It's speaking this. Yeah. This because it was big from the feedback there. Okay. Yes. The problem is that here Michelle is opening the speaker, and it's taking a feedback from the microphone that is here, so it's getting a feedback. So all of you, so we have, okay, so Eloisa and Ming Xiang, if I hope I'm pronouncing that correctly. It will be complicated. Ming Xiang, or sorry if my phonetics is not right. Oh, okay. Hello.
Yeah. Hey, how are you?
I will not be able to hear you. I will be a bad idea. I want to turn on the speaker here, but this computer doesn't. So, so we at least we can. I know that you are from Davis College, and that's one thing. So you also work on genomics. It's bioinformatics somehow, right? Yes. Okay. So okay. So the next. So this one. Okay. So that will help me because at least you both will benefit from the next today. So I will make a special thing about this because this is important for you both. Probably more than Michelle. I don't think Michelle takes much advantage of Conda, but Conda is really, really important for you because if you are doing genomics, most of the codes in genomics that we support are now from Conda environments, and in particular from BioConda. So I will show you how to create your own environment with the package that you want. and you keep control of all the software, so you can work with that. So so this one is really so this one probably is the most important session for you for the Davis College. So I will try to do my best to be clear. So please don't hesitate to write in the chat if something is not clear. So now, Conda. Conda is a tool for what we call environment management. In lay terms, is basically having a software that is consistent, that you can install, manage, and kind of isolate from the rest of the operating system. And that is particularly important, for example, for bioinformatics, because in that particular research area, there are literally thousands of packages doing all sorts of things. So it's really hard to keep track and installing and keeping update that number of packages if you have to install those packages by hand. So that's why we rely on Conda for doing that. So if you search on internet, there are two flavors of Conda. One is called Anaconda. That is something that I recommend you to install on your own computer. It will give you a full Conda environment with a lot of good packages. It's more intended for desktop users, for personal users. And we have Mini Conda. This is the flavor that we install on our cluster. This is a very minimal, lightweight installation of Conda that allows us to have from there multiple environments. So environments are like switches that you can enable, and in there you can install packages, a set of packages for you. And let me before I move down, now that you know that you have that you both work in bioinformatics, yeah, I will just diverge for 3 minutes and show you this in Jupyter and in the Open On Demand that I forgot. I just simply skip it. Here, if you go here in Jupyter Notebook, here you go here in Python via Singularity, and we'll talk about that in a minute, about Singularity, what it means. Here we have a Singularity image that we call bioinformatics. Someone in, I think it's biology, requests like a set of packages, big set of packages. So here I create a Singularity images with a bunch of things that make sense for bioinformatics. So you can use this one here, this image. It will open Jupyter Notebooks, but that image in particular has a lot of packages related to bioinformatics, mostly genomics, of course. But so now, let's go and practice how this works. Conda. So the first thing is module load Conda. So they will show you the trick that you have to do. I think that is still, that would enable that, but usually it's a good idea to just do this. So if you want and you plan to work with Conda for most of your research, you can put this on your Basher C, which is a probably a good idea. Basher C, you go here, you edit with your editor. It could be Nano, it could be, it's because I'm familiar more with here, and you can enable the Conda bar. So, and just attach this line. at that moment, you will always have Conda enabled no matter what. So that's one thing. So that's why I put the recipe here when you execute module load Conda. So it's exactly the same as how it is. With the advantage that now you are explicitly indicating that you are in a Conda environment, and you are always in a Conda environment. When once you load this, you are always in a Conda environment. And the first Conda environment that you have is called base. So you can see Conda M, all the environments that are available here on the system. Conda M list. Okay. So this star indicates that I'm on the Conda M, the Conda environment base. Here I have a bunch of environments. All those environments here are environments that you can see. All those are central installed. And we will see this. You can also have your own Conda environments. And those environments you control, you can create, you can delete, you can install any packages that you want there. Those are under your complete control. So here I have a few, and you will notice why that is so particularly interesting for you. So here I have this genomics core A and B, so the different versions of those are basically the same packages. It's just that instead of updating this one, I prefer to create a new version in case that someone prefers or needs older packages, so he could rely on this other Conda environment. So let's see how this works. Conda activate. Let me see, I will activate this one. Now notice that when you execute this Conda activate, here the prompt changes, and whatever is your personalized prompt, you will add this in front of it. And you can see which are the packages installed in that particular Conda environment. And this one helps quite a lot. So you will be probably familiar with packages here like BCF tools, and those come from Bioconda, so I will show you that in a minute. String type, some for short readings, this String-O-Matic, let's see, SRR tools, well, some tools. This is de novo, sub de novo. Those are basically dependencies here for some other things. BAM tools, BCF tools, BED tools. If you that are in that area, you're probably familiar with those set of tools. FastQ, FastQC, Diamond, BWA. So BLAST, this is well known. So you see Emboss. So many packages here, especially all those that come from Bioconda. All those are for bioinformatics. So this is a nice set of packages. Got this one. This is a Java code. So that's why this is probably bringing some Java around. So all the packages and the dependencies for those packages. So this is a coherent set of software that is available to you. So Mon, Conda, and list. What else? Squime. This is another. This is just one environment for this software. So you Conda activate, so you can skip from one environment to the next one. No, well, in this case, it's the first time that I'm opening this. It will create some files, I think. So let me see in the meantime. So this is how you source it, or module load conda. It's okay. This is one other way for looking at the list of environments that are available there. Or I just type conda and list. This is how you activate the conda environment. And we use this. You can also deactivate. I never deactually that, but now. So now I am in one through here. So conda list will show me the packages. This one has a lot of dependencies. So it's just one package, but it has a lot of dependencies. So you will see the things here. So so the packages here, a lot of R things, Python Perl. So it's just all the dependencies needed for this particular package. One. Let me see. By the way, let me see. If you are not super familiar with this, I can show you Bioconda. Here, you can access the list of packages. So you can start searching. They have a lot of packages. Let me see, Blast. Blast should be around there. So you go scroll, or just click search Blast. So here. So you can see Blast, all the versions that are available. So you can install a very particular version of that package, and then we'll download all the dependencies for it. Also, which package depend on this one? Oh, okay. So this one is a low-level package. So many other things rely on it. Another one, Trinity, for example, is around here. So this one has some dependencies, and you can install this. By default, it will install. In a minute, we will try to create, for example, one for Trinity, the latest version. But you can also select a different version if you want. So Bioconda. Check this, they have more than 7,000 packages. Okay, I forgot to deactivate this. So conda deactivate, and you return to the previous one, conda deactivate, and you return to the base. If you execute this, you return conda and this. You are still in base, but not explicit. Conda activate. Now, you always are in one environment somehow. What else? Okay, so now imagine that we would like to create a new environment. So I will be creating this if I don't have this. Oh, I can create. Let me see. Conda and this. Let's try something different. So you can see the document there. Conda. This is what this is. Okay, so the instructions are basically like this. So conda create and the name of the environment that you want to create it, and this end. Perfect. Okay. Okay, so this is a good example of why this is so nice. You can continue here, see where I was working. I think I was working here. Yes, so I recovered my work with the Tmux. So now we can continue. Okay. 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 We were creating a new one, a new content environment. Let's see. I would like to create Trinity, for example. This one. How they create Trinity. So it will create the environment. This is an environment that is only visible to me. It's Conda Conda environments Trinity. I would say here the name is okay. Yes, and now I will go and Conda activate Trinity. So this right now the Conda has nothing. Conda list, no packages. Next pack, I would like to install Conda install on BioConda Trinity. So it will say, okay, yes, I will install this for Trinity, this particular version of Trinity with this build. So it will tell you all the specification from BioConda. So this one will come from there. And all the dependencies. I also activate the Intel channel. I have the Intel channel in my list of channels. That's why it's speaking some of those from the Intel channel. But which is a good idea because some of them are optimized for Intel processors, so will give you a better performance. But it's not mandatory anyway. So you want to proceed? Yes. So it will start downloading all the packages. It will probably take a while. And in the meantime, we will be talking about something else. But yes, so it will be on the background here, will be building that environment for Trinity. And again, this is exactly the same kind of thing that you can do on your own computer if you want to use Anaconda or you have Anaconda installation. You can install those packages on you, or you install this Windows subsystem for Linux, so you will have like a Linux environment, a Linux kernel running on top of your Windows machine. You can have Conda there and you can install packages the same way. What else? So here, basically, this is an alternative demonstration with a different package, but everything will be pretty much the same. So we'll install the packages, and after you can see what is in there. You can also build a conda environment with a very particular version of Python, for example, or a very particular version of any other package, but for Python this is especially true, because we are no longer supporting Python 2.7. This has been deprecated or no longer supported since 2020, I think. 2020, yeah. So we have still on Spruce Python 2.7, but if for some reason you need something, this is one solution. You can create a new environment with a specific version of Python, for example, or a specific version of a package that you know that have a future, or you have the inputs and the inputs are no longer compatible with new versions, and you want to stick with the old version. This is one way. Okay, let me see how far. Okay, it's done here. So here, conda and conda the list, you can see all the packages and versions and channel that was used for installing those packages. And you can conda deactivate, and you are back to your base on the base environment, and only when you activate Trinity, so conda and list, you will see that Trinity here is a conda environment that I create for my personal usage, and is on my home folder, so just belong to me. So okay, let's see, conda create name 6.7 Python 1.7. Let's see why. Yes. So what else? Searching for packages. So you can say, okay, let's see. Yeah. So Python 2.7, for example, you want to create one for it. It's actually picking Python 2.7 from the Intel channel. So okay. Activate Python. Python 7. I put it. I type with it Python. Anyway, conda search, for example, a specific package will search for all the channels that I have enabled. Which versions of that package are available? For example, I would like to search in the channel in BioConda, and there is something called SunTools. So you get all the versions available. So unbuilt. So it's eventually the same version could have different builds. So it could eventually mean that that version requires a different set of dependencies or different versions of the dependencies. So eventually, if you install other packages, it will try to pick one of those that is compatible with all the dependencies that you have. So okay, some important channels. It's the Intel channel that has Python. It has MKL. So a few packages optimized for Intel processors. Conda Forge has many packages. So people, those that we create packages, that we create software for others, we have packages there. So I have one of my packages there in Conda Forge. BioConda is exclusively for bioinformatics, so it's a nice collection of packages for you in this area. And okay, and this is how you install a package. From a specific channel. So you search. Okay, you can go and install, okay, very specific version. Let me see if I can do something like this. So I can go and search for this one. And I can install MKL from the channel. So you can be very specific from the channel Intel. I know that this is there. This version, this particular version, for example, and okay, this is okay. No, this one, for example, this one has two versions here. So I would like to use this one and this one. You can go and select very specific. I don't know if I will break dependencies. It will tell me if I will break. Yes, so it's able to satisfy my request. So I would like to add this package here to that Pi7 environment. We'll download that package and we'll install it. And what else? Okay, this is something that is another nice tool. You can create recipes and you can search those recipes. For example, if you are working with somebody else eventually in a different university, in a different country, and you want to keep a consistency on the software that you're using, on the kind of packages that you agree will be the packages for that research. You can create a YAML recipe for creating an environment with a very specific set of tools, or a more generic recipe like this. So this is kind of a generic recipe here. So I will show you how this works. So you create them all. That's why it's better to set this. Okay. So this is a YAML file. See Bowtie. So I would ask for BioConda. I specify the order of channels that I will be using and the package that I would like to install. So you can have something like this. A recipe here. I have another recipe, and you can use something like this to create a specific environment. Conda create -f from this recipe. No. Conda deactivate. Conda encrypt. Yeah. Oh, maybe it's this. Not sure. That's right. Okay. I need to check why it's no longer working. Okay. The list of packages. Okay, how to use this in a submission script? Okay, once. So we know that, for example, we want to use Trinity. So on the activate. I have no idea what to do with that package. So it's I would use, for example, this. Again, I have no idea what to do with this. Well, yeah. Now, at least I can put the whole. This is not my area, so I have no idea. So let's create something that uses this. So being run job .pbs. So okay, this was something that I create for something else. Let's see. I can delete this. This is okay. This is not so okay. Or forget about this. Module load conda. Conda activate Trinity. At that moment, you can use this. And all the command lines that for those who know that this code should be doing will use. So this is how you follow the commands to activate Conda, activate the Conda environment that you want. And at this point, all the commands after that will be executed. So you submit this, sub, run job, yes. And I expect to see this output. For a real execution, it will be doing the operation as usual. So this is how you act. Okay, you load Conda, you activate the environment, and you execute the command. And if you want, at the end, you can deactivate. Also, you can change this thing. So you can activate one environment for doing one analysis, and after you want to do a different analysis, you can activate a different environment for the next step in the pipeline, basically. So you can change those execution on a single submission script. There are here instructions for removing a Conda environment. And if you want, you can install Mini Conda or Anaconda on your own computer. That's it. Okay. I will take a couple minutes to figure out why this is not working. And we move, let's say, 5 minutes. If you can explore by yourself and with these environments, try to create one that has one of those packages that you know. And I'm still puzzled why this is not working. Okay. Okay. So this one was the part where I got stuck a minute ago. It was an indentation issue. So here, I have it like one space here, and it should be on the same line, and that's important for YAML. So here I have one recipe for installing one particular package. So this is a generic recipe. It will install the latest version at that moment for this recipe, for this package, on these channels. The order matters. It will try first to search for a package here, after Conda Forge, and finally on defaults. And that's true when you have, for example, the Interpret. If you want to get it more relevance compared to Conda Forge or not. So in this case, this is the right order for this kind of thing. So this is one way of creating a recipe that you can share with your colleagues, and all of them will agree that when they do any analysis, it will be based on packages from this, so you don't get inconsistencies. But also you can be very specific. So the kind of declaration like this that I exported from the code environment, where I am actually declaring the version and the version and the build for one given package. For example, what is this? Bowtie. Here, Bowtie version 2.44 from this build. And that way you can share with others that this was the selection of channels. Those are exactly the versions of the package that will be used for the research. And this doesn't matter if you have a different set of packages on your own machine. So when you do certain analysis, everybody will agree on having the same software and should produce the same result. So now, I think we have time for moving to the next session. That is Singularity. Singularity. So Singularity is another level of isolation that you can achieve in software. With Conda, you are just creating an environment which in fact it translates in searching the packages from one specific location and kind of putting behind the packages that belong to the operating system. Now with Singularity, you achieve a much better isolation by running an entire file system from eventually a completely different distribution of Linux. So we use it for some packages or collections of packages, for especially those that rely on graphic user interfaces, that are complex software, that has a lot of dependencies that we cannot satisfy easily on every single compute node on the cluster. So for certain cases, we use Singularity. For those familiar with containers, are probably more familiar with something called Docker, that some people also in bioinformatics use Docker containers. We cannot support Docker containers on our cluster, and Docker containers rely on having super user capabilities, something that for a shared infrastructure we cannot provide. Singularity is the solution for the HPC community to have on the same facilities, the same features, without having to give super user capabilities for running images. So we will see what we have, where they are, and what you can do with that. By the way, this is one step below the next isolation level. That is a virtual machine. The virtual machine is really a piece of software that mimics hardware, and you run an operating system on top of that simulated hardware. It will be slower. It's much heavier computationally running a virtual machine. When you are running, for example, Linux on top of Windows for WSL version 2, you are actually running on top of a virtual machine. It's a very light and efficient virtual machine. The I/O is particularly good, but it's still a virtual machine. So that is not what we are talking about here. Those are not virtual machines. You are running Linux from a different file system. So you can have, for example, an Ubuntu file system on top of our cluster, and our cluster is running Red Hat, which is a different distribution of Linux. So that's the idea that we are running here. So how we run this? Let me see. I will actually create a new one here. First part, module load Singularity, and now you can run, and all the commands that usually translate into Singularity is something. So we have most of the newer images here in shared containers. So you will see, for example, this image here. The model images have the extension SIF. So this image here has a lot of software related to bioinformatics. We have here, for example, some images for Avinit, some generic images for CentOS. This one is Abstract Algebra software. This one is for physics, is simulating Maxwell equations. Some, let me see, PyTorch for those interested in neural networks. Several versions of Python are here, containerized with more packages. RStudio, this is when you run RStudio on Open On Demand, you are actually using some of those images eventually that we have here. TensorFlow, no, here this is in astrophysics. TensorFlow is around here. So those are the images that we have. And all their images are in shared software containers. So those are kind of old, and they will probably disappear at some point. That we have BMD, visit, those are graphic user interface packages, Maxwell. In bioinformatics, I think we have something, Stack, something for population genomics. It's right here. Stack, several versions of that. This one is astrophysics. This is CASA. This is for geographic information systems, GRASS, Maxwell. PowerView is a visualization tool. So this is like a review what we have. So how that works, let's do it for something like the bioinformatics. So Singularity, shell, and share containers. Bioinformatics 221. This is how you execute, how you enter in the shell of a Singularity container. So here, I think I have BLAS, I have some tools. I will try to remember what is inside. Here is the setup. Okay, so on here I install for this bioinformatics, I install BLAS. All those packages are here, installed already, isolated. So this is another thing, you can share either the image, and someone with the image can execute exactly the same on their own computer, on their own cluster. If they are from a different university, they can just take the image or take the recipe and recreate the image. This is the recipe, by the way. This is the recipe for creating a Singularity image. So all the commands that were executed for that, and we have those packages there. And we create that. This is actually a Singularity image that runs mini Conda. It has Conda inside, and inside that Conda, we install a few packages that create a lot of dependencies. So we isolate those with different environments. So Trinity was one of those. Canoe, Genome Tools, and OrthoFinder. Those are kind of problematic. They create a lot of dependencies and they collide with some other packages. So we isolate those with Conda environments. So this is a mixture. This is a hybrid thing between Singularity containers and Conda environments on the same thing, package on a single image. So something that we can distribute. What else we can do? If you want, for example, BLAS, I don't know how the BLAS works. BLAS, something. That's X. Wow, yeah, something like that. Was help. Okay, something like this. So it will show me all the commands. If you want to execute this from outside, there is a different command here, exec. And you don't need to actually enter on the shell to execute the command. So this is a way of using software that is inside the Singularity container from outside. This is actually the way you will use it for submitting jobs. So you create a script and you submit the script with the command that you want to use or the command line that will be appropriated for that. So let's see what we can. So Singularity, I show you this, how you get a shell inside Singularity container, how you prepare a submission script. This one was for an old and previous version of Singularity. You don't need to specify the version here. So you can perfectly remove this. And Singularity exec, the name of the image, and the command that you want to execute. And you submit. This one is a small exercise for running R, for example, and install your own packages in R. So this is actually something that I can demonstrate. So Singularity, shell, and share containers are, let's say this R version 0404 set. And I can execute R and install packages. Let me see. For example, let me see. We could write something. Let's see deep, something small. Maybe. Great. Okay. So basically what I'm doing is I am loading a Singularity container for R, and I'm installing packages for me, even if I am inside the container. So all those packages will be installed on my home folder, even if the image will be, it's a read-only, it's a read-only entity, so you cannot modify the image, which is a good thing, because if something happens, you can just delete and recreate. Probably it fails with div because I need a dependency that image, so that is a particular case. So I choose wrong example for that, but something like this, it will work. Yeah, this one was filed with some statistics of census, and I have here, like, this is more for R, and an R script that is right here, and as an example, and then the exercise is to create an analysis of the data from the census, US Census, using the image that we have inside, that we provide for R. So, this one is like a note aside, how you create your own images. You can create your own images if you're running on a Linux machine, on your own machine. So for creating images, you need to be root, you need to have super user capabilities, but you can still do it. So this is like a tutorial on how you build an image step by step. You can create that image on your own, and you can transfer the image and run it on the cluster. So that is another thing that you can do. So you can have your own software, containerized, and basically what I'm doing here, I start with a very vanilla, very pristine CentOS image, and little by little I will be adding some packages, some libraries, until I will execute some software. It's a graphic software that produces some images, some fractals on the screen. So I'm going step by step building the image that give you that. So this is basically all that is relevant to this. So yeah, this one works. So okay. So all the commands that you actually use most of the time is this one, and this exec, Singularity shell and Singularity exec, the image, and you have a bunch of support for execution. So we went good in terms of the time. So I think that we will stop around here. If you have questions, we have a lot of time, but today we were good on the schedule for this. So for tomorrow, we will start with Git, how you create repositories, how you version control. I have two examples to show you. One for a paper, for example, you have your script, you have the data, you put and you version control a paper or a thesis or something like that. And for a small piece of software development, where you will be editing the code. It's a small C code for the tutorial, and so you will learn how to use version control system. By the way, you can request with us a private repository. GitHub offers private repositories for a price. I think we still have that agreement in place, so we can offer you private repositories in case that you want to use those for your thesis and you want to keep privacy on those. So we can open a repository for you private, and you can tell us who you want to share that repository with, your advisor or something, or not. And that's something that we will see tomorrow. And compiling codes, or like an introduction of compiling libraries, what is behind curtains when you are compiling a code. This is a good thing to know. And a little bit of shell scripting, which again is something that saves a lot of time when you know what to do. For example, for editing files on scripts, grabbing or extracting columns from text files. You can do a lot of things just with a few commands if you know a little bit of shell scripting. Those are the topics for tomorrow. So today we pretty much finish. If you have questions or you want me to explore somewhat special topic, I will do that. So feel free to ask. And I will be here